talk about radioactivity and nuclear energy. You have known previously that all elements consist of atoms. The atom consists of a nucleus surrounded by electrons revolving around it in certain energy levels. The mass of the atom is concentrated in the nucleus, which contains protons and neutrons. The composition of the atom is responsible for the physical and chemical properties of the element. Chemical reactions between atoms occur through their outermost electrons, while nuclear reactions occur due to the change in the number of protons and neutrons inside nucleus. As we said, nucleus consists of positively charged particles, which are called protons, and neutrons, which are neutral, they have no charge. As it consists of positive particles, there are strong repulsion forces between protons. The question which rises up in this moment is, how can the nucleus be stable if there are these strong repulsion forces between the protons? What makes this nucleus being stable? What makes nucleus being stable are the nuclear binding forces. Nuclear binding forces are those forces which are necessary to bind the nucleus components together and overcome the repulsion forces that are present between the positively charged protons and each other. The nuclear binding forces are considered as the source which provides the atom with a huge energy, which is called the nuclear energy. So the atom's nucleus is considered as the energy store. We know that in the periodic table there are some atoms of elements. Their nuclei have suitable number of neutrons and make them stable. So we have stable elements in the periodic table, and we have some other elements which they are unstable. These are called radioactive elements, such as radium, cesium, selenium, polonium, zirconium, rubidium, uranium. But what makes these radioactive elements unstable? Why are these elements unstable? They are elements whose atoms' nuclei contain a number of neutrons more than the number required for its stability. So these radioactive elements are all the time in an attempt to achieve a more stable composition. How do they achieve this more stable composition? They achieve this more stable composition by emitting invisible radiation such as alpha particles, beta particles, and gamma rays. This phenomenon of spontaneous decay of the atom's nuclei is called radioactivity phenomenon. So radioactivity phenomenon is the spontaneous decay of the atom's nuclei of some radioactive elements that are present in nature in an attempt to achieve a more stable composition. The scientist who discovered the radioactivity phenomenon is the French scientist Henri Becquerel. Henri Becquerel accidentally discovered that phosphorescent uranium salts, even when they are not exposed to light, they produce spontaneous emissions that darkened photographic plates. So he called these elements radioactive elements, and the phenomenon is called radioactivity phenomenon. The radioactivity is not only natural, it doesn't happen only spontaneous, it is also artificial. Artificial radioactivity, it is the radiation or nuclear energy that is released during nuclear reactions, either from nuclear reactors or nuclear bombs, which can be controlled or cannot be controlled. Yes, artificial radioactivity can be used peacefully, and this is controlled, or can be used in military, and then in military sometimes it cannot be controlled. For example, in the Second World War, on August 6, 1945, an American airplane dropped the first atomic bomb on the Japanese city of Hiroshima, eventually killing over 140,000 people. On August 9, 1945, the United States of America dropped the second atomic bomb, and this time on another Japanese city of Nagasaki, and it killed 75,000 people. However, as much as it looked scary, we can use artificial radioactivity very well for our benefits. So artificial radioactivity can be used peacefully and we can benefit from it. The fields of using the nuclear energy can be medical field to diagnose and treat diseases like cancer. We can use it in agricultural field to eliminate pests and to improve some plants' race. We can use it in industrial field to convert sand to silicon sheets, which is used in manufacturing computer processors and program electric circuits that are used in electric appliances, or to discover defects in the manufacturer's products. We can use it in electricity generation field to heat water to produce steam. This steam is used to operate turbines to generate electricity. We can use it in space exploration field. The radioactive materials are used as a nuclear fuel for rockets that fly into space, or we can use it in drilling field, drilling for petroleum and underground water. So as you see, there are many fields where we can use the nuclear energy for our benefits, and these are called peaceful uses of nuclear energy. However, using the radiation makes too much pollution. Radiation pollution, it is the increase in the amount of radiation in the environment. Radiation pollution can come from two sources, natural sources or artificial sources. Natural sources, they are natural radioactive materials which are found on the Earth's surface, or cosmic radiation that comes from the outer space. These natural sources are sources which are out of our people control. They just happen naturally, spontaneously, automatically. Artificial sources are the explosion of nuclear bombs that some countries do as experiments from time to time, or the nuclear reactors. Example of radiation pollution, it is Chernobyl nuclear power plant. Where is this Chernobyl? Chernobyl is in northern Ukraine, 10 miles away from Belarus, or 8 miles north of Kiev. Here, as you see here, this is the Chernobyl nuclear power plant. What happened in Chernobyl nuclear power plant? An explosion occurred in 26 April 1986. It occurred as an error in operation. What happened? The melting of reactor core led to nuclear explosion and the release of many radioactive elements. These elements formed a cloud which was carried by the wind to many European countries. When rain fell, it carried radioactive elements to the Earth's surface. The plants and soil were polluted by the fallen radioactive elements, iodine and cesium isotopes produced from the decay of uranium. So the uranium radioactive elements decay, and it produced cesium and iodine isotopes. What are isotopes? They are atoms of the same element that contain the same number of protons but different number of neutrons. What are the paths to contaminate the products? First, as in the case of the Chernobyl nuclear power plant, as the explosion happened, the air got contaminated, formed this cloud, and the cloud flew over the Europe. This cloud these radioactive elements which were in the cloud, they came down through the rainfall. The rainfall carries radioactive elements which fall out to surface water. So as the radioactive elements fall to the surface water, the fishery products contaminated, plants and animals contaminated, soil contaminated. The animals are eating these plants, they feed on plants and they got contamination. The humans get contaminated because we eat vegetables which are already contaminated, and we eat meat or milk from the animals which are contaminated. So these are the pathways of radioactive contamination to agriculture products. Radiation effects on the human body. The effects due to exposure to a large dosage of radiation for a short time, 1 day or less, will lead to damage. So, if we are exposed to a large dosage but for a short time, we will get damaged. The spleen will get damaged, digestive system will get damaged, central nervous system is going to get damaged, and bone marrow, which is responsible for the formation of blood cells, is going to be damaged. The damage of bone marrow will lead to the decrease in the number of red blood cells in the human body. We can also get damaged if we are exposed to a small dosage of radiation, but for a long time, months or years. For example, if our flats or the places where we live is next to a nuclear power plant, so we can get small dosage, but in a long time, months or years, and this one can affect us seriously. Physical effects, genetical effects, or cellular effects. So, physical effects, they are changes that appear on a living organism as a result of exposure to radiation, like skin cancer. Genetic effects, they are changes in the sex chromosomes composition, which can result in abnormal birth. Cellular effects, it can affect the cells. There are changes in the sex chromosomes composition which lead to destroy the cells. So, to avoid being damaged, being contaminated by radioactive elements or radiation, there are means of protection. Means of protection from radiation pollution. Especially the workers with radioactive elements in labs and hospitals, they should wear radiation protective gloves, clothes and masks. Radioactive wastes should be away from underground water path to prevent its pollution. The area chosen for storing radioactive wastes should be a steady one, not exposed to earthquakes and volcanoes, and away from the animals that live in caves to prevent the spreading of the radioactive wastes in the surrounding environment by the effect of earthquakes or volcanoes. Burying of nuclear wastes according to the radiation power emitted from it. There is mild and moderate nuclear wastes. These mild and moderate nuclear wastes can just be surrounded by a cement layer or rocks, but if there are strong nuclear wastes, they must be buried deeply inside in the ground. Issue laws for nuclear stations to cool the hot water before throwing it in seas and lakes. And the last part of this lesson is measuring radiation. The International Measuring Unit of Nuclear Radiation absorbed by the human body is a sievert. Sievert, according to the scientist who discovered this, 1 millisievert is 10 power minus 3 sievert. The safe dose when exposed to nuclear radiation for radiologists, people who work at nuclear radiation fields, is 20 millisievert per year. For public, for us, is 1 millisievert per year. The safe dose, however, depends on age of the person, the period of time in which the person is exposed to nuclear radiation, the part of the human body that is exposed to nuclear radiation.